everybody, Mrs. Bixler here, and we're starting our second unit. I mean, technically it's our third unit, but whatever. Logic, unit 1, and then this guy. And this is called the Introduction to Algebraic Geometry. And you're going to see what we're doing here is we're sneaking some algebra problems into some geometric figures. It's pretty exciting. So we're going to use all the geometric concepts that we know from unit 1, and we're going to just sneak in some algebra. So before we get started, I wanted to make sure that we could do a little factoring, because factoring's back, baby. Pause the video, do it. All right, we're back. So if I scoocha here, you figured out that factors of 26 combined in some way to get you 11. That is -2 and 13. And then you solved and got x equals 2 or x equals -13. All right, let's try the next one. Pause the video and then we'll come back. All right, we're back. So hopefully you noticed, wait, I can't find factors of 15 that combine in some way to get me a -4. So for this one, you had to use the quadratic formula, the quadratic equation, which is so exciting. So we love the quadratic formula, and this gives us this. But if you noticed underneath the square root, you wound up with NRS, no real solution. And so because it winds up being negative, right? So whatever the square root, if that gives us a negative value, then our final answer is NRS. So you should feel pretty good about those. If you don't, go ahead and do a little factoring review before you move on to the next problem, which is, okay, pause the video, try to solve it. So we're back. So hopefully you figured out, you know that we got a linear pair here, right? And because of the subcost, we know that they are supplementary to each other and they add up to 180. So you set up an equation and it looked like this. Then you did a little simplification here, adding 222 and subtracting 180. And then you just had to factor. So if we just factor like this, we get x equals 6 or x equals 7. Done. Fabulous. So what we just did here is we snuck some factoring into a geometric concept, which is kind of cool. You probably might not have been able to do, I mean, I'm sure you could have, but this problem prior to all the stuff that we learned in unit 2. Maybe this one you could have done, but there are going to be some other ones that you'd be like, I'm not exactly sure how to set that up. So now let's try this one. Pause the video and go for it. All right, we're back. So this is super important. I know that A is the midpoint of MT, so I know this is congruent to this guy. So hopefully when you set up your equation, all you did was you just set them equal to each other. So you set them equal to each other, 50 equals 5x plus 5, and then you solved for x. All right, next one, try this one. All right, so you might have seen a little on the bottom, but look, so AB equals 31 and CA equals 4x plus 12. This problem is actually not possible. And it's not possible because I don't know that A is the midpoint of BC. But if I gave you this, go ahead and pause the video, set up your equation, and solve it. All right, we're back. So hopefully you noticed, wait a second, this is the segment addition postulate, right? CA plus AB equals CB. So you can set up your equation that way and then solve for x. Now we can do this for line segments and we can also do it for angles. So go ahead, pause your video and try these 4 problems. Go for it. All right, let's look at the first one. Hopefully you set up your equation. Whoop. So hopefully you set up your equation so you knew that these guys were going to be equal to each other. So easy peas, x plus 5 equals 2x minus 10. The second one, this is compost, right? So I know that they are going to add up to 90, and then you solve for x. The third one, this is subpost. So I see a straight line, I know that they add up to 180. And then the last one, this is the angle addition postulate, right? 2 smaller angles adding up to a larger one. So this is a lot of information, and you're able to know a lot from this. So let's try this next one. Go ahead and solve for x here. Now you've got to be careful. We're back, and you got to be careful here. You don't just want to set 5x plus 1 equal to x plus 4. So watch here. We know that DBC, this whole angle here, is 5x plus 1. And all I know is that that angle plus angle DBA add up to 180, right? And but I know that angle DBE, so DBE is x plus 4. So given this information, there are a few ways you could set up this problem. And here's what I did. I just said, well, I know if DBE is x plus 4, well, twice x plus 4 is going to give me both DBE and angle EBA, right? And then if I add 5x plus 1 to it, then I can just set it equal to 180. And then you can go ahead and solve. If you did a different way, I would love to hear it. All right, last problems. Go ahead and try these two. Okay, we're back. So hopefully with these, you recognize that you had vertical angles. So this is the vertical angle theorem. So all you did was just set the two things equal to each other. 3x plus 1 equals 4x minus 10. But this second one is a little different, right? We're solving for x and y. So you want to solve for x first. So you do a little subpost. So you know that 3x plus 5 plus x equals 180. And then once you know what x is, you can plug it in to this guy. And then you know that this and this are congruent because they are vertical angles. So then you can set them equal to each other and solve for y. Good? All right. So go ahead, crush that worksheet, and I will see you soon. Thanks.